Like I said in the first part of this video, I'm making the second part that's going to be more focused for my tech is right. So it's going to be more focused on my thought process and it's perfect for the technical audience. And this is that part too. So welcome guys to this walkthrough of my work notebook and my analysis. So I'm going to like just try to skim through guys. But when you go through the GitHub repo, you're going to this notebook, find the notebook there and you can get more details, right? So this is just the introduction section of the page, and then you have the business, you have the background, the key questions. These key questions actually came from the projects on DataCamp itself. Then the project goals, so for the business and the data science aspect, then the tools and skills that were used as well. Then the data, so the data was gotten from cargo, and this is the link to the data. And we have some the data dictionary. So we have the ID, the year, the month, departure schedule, departure time rather, sorry, and schedule departure time, and all of the other features for the data set. Then the lookup table. So this is the carrier code. This table was joined to this table on the on this column here and on this column here. So importing libraries and loading data sets. So I have all the I just like separate mark them based on their use or where they were used, right? So data wrangling and visualization, these are like the necessary libraries, then the clustering libraries, then the preprocessing, modeling libraries, class imbalance, miscellaneous. So this is how I imported the data actually. This was when I used my Google Colab, right? So I imported from Google. I used Google Colab for analysis. I'm just like showing you guys on VS Code, but I use Google Colab for analysis, right? So this was the link for importing the data sets. Then I also I do some customization. So since I got the project from DataCamp, I said to like use DataCamp's color scheme for my project. So these are like colors from DataCamp. I just thought to use it on my project. So also I wanted to like use this font too for my chart because I like the way it looks actually. So we have the customization for the fonts here. So for data preparation and cleaning, so effective modeling and analysis starts the well structured and clean data set. And this section applies the key step preparations taken to ensure the data sets were ready for exploration and handling. So the first thing I did was to undo the missing values. So upon inspecting the data set, I saw that features like departure time, arrival time, departure delay, arrival delay, and airtime for some flight details were missing, and these values were typically missing together, so together in the same row, and this strongly suggested that these flights were cancelled, and so they lacked these recorded times. So let me just scroll down to where so we can see the missing values here about 9,000, 9,000, 8,000 here. And I created like a missing chart, and we can see from this, we can see that where we have missing value here, this also is also missing, also missing, also missing, so also missing, this one also missing. So there's a sorry, there is some kind of relationship between the missing values, and that indicated that the those flights were probably cancelled. And for that reason, I just chose to drop those affected rows, right? To focus on only flights that were not cancelled, right? So I started to drop those missing values, and there were a total of about 2.8% of the flights of the data actually that was dropped. So over 97% of the data sets was still available for analysis. So I feel like 2.8% is not really that. Those is very, very little, and I went ahead to like drop those parts. Also, I went ahead to like standardize time and date features, right? So for the month column, they were originally in numbers. So January was in one, February was in 2, 3, and 4. So let me just scroll down to that part. So we can see for the unique numbers, for the um unique features, sorry, unique values in the month column, you can see 1, 10, 11. So that's the months were actually represented in their number number form, or their number position, their position number initially, and then I went ahead to like map them to their more um intuitive values like January, February, so that it can be visualized easier and easily understood. You don't have to like start thinking, oh, month 7 is July. You don't have to like, once you see July, you know it's July. Also, a new column, day of the week, was extracted from from the existing date column to reflect the day of the week, right? So I noticed that in the data set they had for the day column, they were like days of each month, right? So for each month, January had 31 days, February had 28 days, and all of that. So I went ahead to like extract the day, the actual day of the week from that value, yes. So let me just scroll down to where I have that part. So here we can see for the day column, the unique value were from 1 to 31. So each month had its own exact number of months, exact number of days rather in the month. And what I went to do was first to create a days column from the year, the month, and the day. And from there, we created the day of the week column that extracting the day parts of the dates, right? Then from there, I went to define the natural order for the days, so from Monday down to Sunday rather, and then created from the day of the week. I used the categorical PD does categorical to um ensure the categories were ordered and then they were mapped to their proper intuitive day. That is Monday, Tuesday, Wednesday, Thursday, Friday. And this is like the value count for each flight. Also, so this was the codes for mapping the months to their intuitive values also. I also went ahead to like rename this airline name column that we got from the second table to this one with the I think this is the snake pattern of naming features. So I just, instead of having to like type this every time I want to like use airline, I just want to like rename this one to this easier version. I also went ahead to like create new calculated features, right? So the focus for the predictive modeling was to flag flights that are greater and delays that are greater than or equal to 15 minutes, right? So I went ahead to like create those columns. Departure delay 15, arrival delay 15. So, and that is for flights that are greater than or equal to 15. Now I went ahead to convert them to type integer. So they were in the form true or false before. Then I went ahead to like convert them to integer so that they will be in the form of zeros and ones. So 0 for flights not delayed up to 15 or 15 minutes and above, and 1 for flights delayed 15 minutes and above, right? Yeah, so I also went ahead to like create flag for flight that are delayed for any amount of time. So once the flight did not take off at the scheduled time, I went and like create flag for that as well. So that's if the departure delay is greater than 0, we created this column for it. So as well as like converted to type int because they were in the Boolean form, that is the true and false form before. Then I went ahead to convert them to type int using these code lines here, and this is what a sample of that looks like. So I went ahead to like drop other irrelevant features that were not needed for the analysis at this point. So the year, the day, the year was 2003 for all of the flights. So it's not really necessary at this point. So I went ahead to like drop the original day column, then the departure time, the scheduled departure time, arrival time. I went ahead to like drop all unnecessary irrelevant features that were not needed for the analysis. And this is what the final dataset that I used for my EDA going on looked like, right? So we have the month, departure delay, arrival delay, flight, origin, destination, airtime, distance, hour, minutes, airline name, dates, departure, day of the week, and all of these other features, right? So moving on to the EDA part. So first one was to check our summary statistics using the describe method, right? So I went ahead to like categorize the numerical column and the categorical column. So for the numerical column, the flight column is actually a identifier. So I removed that when I was trying to do my when I was going to call my describe method so that it's not going to just be unnecessary in the table, right? So after removing it, then I went to call my describe method and also like rounded up the values to two so that I don't have to like start worrying about the extra values of the decimal places at the end. So this is what the dots, this is what the describe method for the numerical column looks like rather. And then for the categorical column, you can see the unique month, you can see the month, their unique values, and the top one and the frequency of the top one. So let's just walk through. So this is what the summary statistic overview is, and we have the departure delay is actually right skewed with few extreme outliers at maximum delay of over 1,201 minutes. I feel like that flight won't be cancelled at some point. Then so we said that 25 of flights departed at least 5 minutes early. So while some flights were actually delayed, some flights actually do depart earlier than scheduled, apparently. Yeah, so these are just like notes on this table and this table that we have here. So the distribution, I went as like make histogram and box plot to just see what's their distribution, what the distribution of those numeric columns are to understand if they're outliers and their shapes, right? So for distribution of departure delay, we can see that it's heavily right skewed. Also, it has a lot of outliers as indicated in the summary statistics overview there. So this visualization basically just helps us see what we're talking about in the describe section earlier. So this is for the arrival delay, the airtime, the distance, the distribution of hour, minutes, departure delay and arrival, and all of those other ones. Then for the categorical features, I went ahead to like create bar plots so that the values on the if it was a horizontal plot, right? If some of the values with longer names might be rotated, sometimes like use bar plot so that we can have them on the vertical axis and then we can easily read them also. And if they are very long, that they might need to be rotated. In this situation, we would not have to like work with, we would not have to like rotate them and people can easily read them. So example for this case, if it was on the horizontal line, so that to be rotated. So in this situation now, you can easily read them and understand what's actually going on in each case. So overall delay distribution, this was actually discussed in the Streamlit app. So we have the delay departure delayed for not delayed 61%, for delayed 39% at departure and then at arrival, and then the ones that are delayed above 15%, and those that are delayed at arrival at above 50% and above, right? So yeah, I don't know why this is there, but I have to like adjust this. So airline, moving on to the analysis part. Airline level performance. So this is where I try to like answer the questions from the competitions, right? From the competition. So the first question was to explore airline level performance. So how do airline compare in terms of arrival, departure and arrival? Are some carriers consistently more punctual than others? And this is like after the analysis here, yeah with the visuals and all that. See, I try to like so I've been reading this book data storytelling with storytelling with data rather by Co Knaflick. If I'm pronouncing it right. So that book has actually like been shaping my thought process and working my visualization, right? So I just try to have some code modifications to like create this chart where I have the top three and the bottom three. This is actually the top three for punctual. Sha. They were like highlighted, and this the ones in between are like in more neutral, lesser tone. So we can focus on this top three and this three here. So that's just a way to like just flex my skill a little bit. Yeah, and so from that visual, we are like and for the from sorry from that analysis, I like try to like write an overview here so that it's easier to understand, or just to see at a glance and read through what was actually happening. I actually already like walk through all of this in the Streamlit approach, so that's like go through them. I'm just going to like try to just walk you guys through my process. So the first thing was to use the aggregate method to get the mean and prepare the data. So for each airline, we got the airline name, we got their mean departure delay greater than or equal to 15 minutes, then arrival delay greater than or equal to 15 minutes, and then the total delay as well. So that's what I using the group by and the aggregate method to get this table. Then after that, I went there to like create the chart. So visualizing the chart basically. So for the departure delays, I decided to use the navy green part of the color palette, and then the green part for arrival delays. Then the other part they were not like that they were not in the top three or bottom three. I just used these two gray tones for them. So this is the code to create the plot basically. So using a for loop to iterate over each bar to select whether they fall into the top three or the bottom three, and then append their respective color. That's what this code block is talking about. Then this is the code to actually plot the bar chart. So you first plot the one for the using the bar chart, you first plot this one, and then you stack this one next to it. So you can see that the left is actually this part here, and then this one is stacked to the right. I don't know, I'm going to explain this, but yes, that's basically how to like that's how a bar chart works. So you plot one first, and then you stack the next bar to the right of the one that you plot originally. So it's going to be on the left, and the new one is going to be on the right. So and then annotating the values. This is like the code block for annotating. And that's like do some kind of extra formatting. So that is adding the percentage at the bar. Then I moved this bar chart. Sorry, this axis line from this bottom here. It's usually at the bottom here. I moved it to the top because this is want the user to quickly see the information that they want to see at the top here. So I moved it from the bottom to the top. This is actually a tip I learned from that book as well. So yeah. Then I went there to like remove any extra. I removed the y axis line too as well because it is not necessary at this point. Then this legend, departure delay, then the line arrival delay. So you can see that the first block is going to be the departure delay, and then the second block is going to be the arrival delays, and then the proportion of flights is the um title of this x-axis line. So yeah, and I went there to like annotate this value to the left. Allocate the value and align them to the left rather, and then this is the chart title. So the book actually like shaped my thinking in trying to create this chart. And yeah, this is a code to remove the y-axis label. So PLT dot title, we have PLT dot show, and we have our chart. Yeah. So moving on to the next chart or the next analysis from the question is to explore time patterns and flight delays. So are there specific time in months, days, or hour that these are common? And we saw that in the Streamlit app. So if you've not watched part one, please go and watch part one because we've explored all of this in part one. And also when you read through the notebook, it's actually very, very explanatory. Make sure to like document every finding in the notebook so people can actually understand without having to stress yourself for anything. So yeah, so these are like the summary of everything. So yes, there are clear patterns in monthly trends, in daily trends, and then hourly trends as well. So this is like the code to get the table for delay trends for each month, delay trend, and then to plot it as well. So I went there to plot it, and I had to do some of adjusting to just make sure that the whole visual is not too cluttered and is not too um and it's just visually appealing for people to visualize and understand. So I did the same thing for the weekly delay trends chart too. So first thing is to like get the table for the trends and then use the table to plot the line plot. So for this one, since we are plotting a time series basically, I use a line plot. That's so for the monthly trend chart and then the weekly trend chart. This is the time series. I use the line plot. This is more intuitive, right? So use a line plot to see how it goes from for those trends. Also for the hourly the day trend as well. So the person is to calculate the table that I want to use to plot the data. So using group by and then aggregation and all of that. The table was created and then the plots was actually created. And I also tried to be as minimalistic so that some of the features and like customization so that some of the um default features are not over that are removed so that they don't overwhelm the chart overall. So moving on to the next question, which is the airport reliability. So which airport experienced the most delay and all of that. Also, all of this was discussed in the Streamlit app. So we still have all of the stories here. But I went ahead to calculate the data. Then next thing is to plot, and we arrive at this chart here that is visually appealing. Yes, we arrive at this chart here. And then for the departure, the destination airport too, I went ahead to calculate the table that we're going to explore the data and then went ahead to use Plotly for this one because it's a data with plenty values, right? So I feel like the best chart option was to use Plotly for it so that people can interact with it and know zoom in, zoom out. It's not showing here because I have not really like ran the notebook since I opened it on this Visual Studio Code. So I've not run the notebook, but this particular visual is of the streaming app, and if you run it on Edge, you actually see it. So moving on to the root level delays as well. I have the questions and I also have like the answers here in the tables and in the paragraphs and all of that. So yeah. So when that's like create a root column. So combining the origin and the destination, putting an hyphen in between, we created the root column. And from the root column, we would like get the aggregate for the departure delay at above 50 minutes and above the mean value, and then the arrival, and then the flight counts as well. So yeah, also this one. So I used a plotly chart. If you go to the Streamlit app, all of these charts are there. So I use a Plotly app so that people can easily interact with it. So means zoom out over on the bubbles and then you can see what is going on in each bubble and all of that. Then airline routes delay strength. So this is where we compare each airline and their performance on each route, right? So this is where we understood that um different airlines perform differently on the same route. So this is like the whole story for that. And this is like the code to get the table to calculate the composite score, and then this is the table. It's actually a very long table. I don't know if you yeah, it is long actually. Yeah, so I just went ahead to like show them in a lollipop. I think it's called a lollipop chat here for this visual. But in the Streamlit app, I made it interactive, a totally bar chart. So we can see that on this for these airways, they have like varying performance across their routes. So I made that I select the top three delay pro routes for each airways for this one. But in the Streamlit app, it's much more explanatory, and this is just for this is more just for my analysis part, right? So if you go to the stream list tab, you are going to see much detailed performance of each airways and their routes. So we also have the travel distance. For the travel distance, I went there to like encode them. So I went there to like bin them into short haul, medium haul, and long haul. So short haul is less than 1,000 miles. Medium haul is between 1,001 to 2,500 miles. Then long haul is anything above 2,500 miles. And we can see their performance, the departure delay and arrival delay across these categories. So this is like story. So this is the code to like categorize the code to categorize. I created a function classify the distance to assign each distance based on their value. So for one less than 1,000, they assign the short category and the rest. So this is the code blocks for that. And then the code block to calculate this table. You're using the aggregate, the group by and the aggregate functions. Methods, what sorry, methods. Then the clustering. So we saw clustering in the stream tab. So this is where I did the clustering. So for the clustering, I used K-means clustering. So the first thing was to scale my features, right? So because K-means is affected by scale of the features. So I went there to like scale all of the selected features that I was going to use for clustering first. So for the clustering, I went there to like create the code block to determine the optimal case. So the optimal case is going to be the number of clusters I'm going to end up with at the end, right? So for the K values, I tested from a range of 2 clusters to 8. So this 9 clusters together, I'm working with time and 8 clusters. So and for each one, we're going to like record their inertia and their silhouette score. So using a for loop for K in K values, we're going to um fit a k-means a k-means algorithm to an unsupervised learning algorithm basically. So we fit that k-means algorithm, then we record the inertia and the silhouette. So the inertia basically just helps us determine um optimal key, and then the silhouette score just helps us. It's like a scoring evaluation metric to like, okay, show that at this value of K, this is the silhouette score. And the higher the silhouette score, the more correct or accurate that number of K is um in explaining or break or clustering your data, right? So for that, I mean that like create a chart just like visualize it. Yeah. For the elbow method, you basically just try to look at where the elbow forms and then you trace it down to the number of clusters and pick. And also using the silhouette score as a guide to where you can see that okay, as the number of clusters increases up until for the number of silhouettes, I mean the silhouette score values increases. Then from 4 it continues to like reduce. So I just went ahead to choose 4 as my number of clusters based on the silhouette score and the elbow pointing at 4. So yeah, so I went ahead to choose the clusters of 5, and then we went ahead to like plot. So okay, sorry, I didn't choose 4. I went ahead to choose 5 because I feel like 5 is more explanatory. Yes, yeah, I mean that's to choose 5 for my number of clusters, and then you can see that I mean that's like use the PCA to visualize the clusters that were created. So this is cluster 0. So green cluster 0, cluster 1, cluster 3, cluster 2, and cluster 1. So this is just PCA to like visualize our clusters more effectively, and we can see that they are well separated. I went there to just use five. I actually did the PCA for 4, 3, and all of that. But I just went there to choose cluster number of 5, and then these are the airports that are grouped for each cluster. So we can see we have about 20 airports for cluster 0, about 10 airports for cluster 1, and all of the rest. And so for each cluster, I went there to like based on their characteristics, I went there to like create more intuitive short labels. So moderate delay, low traffic, high traffic, all of all of that thing. I went ahead also to like create the plotly chart that you saw in the streaming tab. I went ahead to create it here. I don't say because I've not run the whole code block since I opened it in VS Code since then. So I also went there to like do cluster analysis of the flight route as well, like we saw in the Streamlit app also. So it's basically the same process as the other one. Get your optimal care using the elbow method and silhouette score, plot and all of that. Then after that, you use the PCA to visualize. So for this one, I went ahead to just choose the four cluster 1, 2, 3, 4. We can see each airport, each route rather that is classified under each cluster. So and I also want to like map out intuitive labels for each one, right? Yeah, and also I went there to like create charts, frame plotly charts, which is there, but you guys can't see it because I did not run this notebook when I opened it on VS Code. So start now ending the ADA section. I'm not transitioning into the modeling part immediately, but before I start modeling, we have to do some feature engineering, right? So the first step was to create the destination cluster. So the destination cluster that we got from the EDA, and what that is like map each destination to their cluster. So we created a column called destination cluster. We also created another column called route cluster, that is to map each route to their cluster. Then I also went there is like calculate the average delays for each airline. So the average airline arrival delay and airline delay. So this is a way to encode each airline numerically. You know that your machine learning model is not going to take in categorical data, right? It's not going to take in strings. So it takes in only numerical data. So I use this particular value, the average airline, the average departure, sorry, the average delays at departures and arrival to actually encode each airline's performance, so that when I go ahead to drop the column of the airline names, we actually have something that is representing those airlines, right, based on their performance. And also when that's like calculate route density, so that is the number of traffic, number of flights on each route. Also, it's like create red eye flight flag. So red eye flights are flights that are scheduled to depart between 10 p.m. and 5 p.m. and they are mostly like cheap flight that people try to board. So and they are called red eye because they are scheduled to take off in the night and then you just land wherever it is you are going by morning, and so you can like rest and all that. So people tend to like take them because they are mostly like cheaper and low cost, and there's hence their name red eye flights and all that. So I created a flag to see if a flight is going to be a red eye flight, if it is a red eye flight based on the scheduled time and all that. So this is like a domain specific value that was created. Then also based on the delay trends from the EDA that was also, so that delay trends especially for like time, month and days changes at specific pattern. So I went there to like create score or just numbers to like categorize. So the higher your delay rate, the higher your score is going to be. So I went there to like create, so for the time block for the month and the departure, so day of the week. So instead of encoding in with label encoding or one not encoding, this one is more specific to what we found from our ADA. So this is very, very important in your data science process. So this right here is like an informed feature engineering, right? So based on what I found from my ADA, I went ahead to create score for each value to reflect their trends. So this is just the code blocks. So this is equivalent to map the root clusters, the destination clusters, then to calculate the average airline, calculate the average airline average delay, oh god, then to calculate the route density, then to calculate the red eye flight, and then to calculate the score. So we saw that the delay trend for the time of the day rises steadily according, so from 12 p.m., 12 p.m. must assign 1 because that's the lowest. Then up until 9 p.m. to 12 p.m. that has highest at score 7. Also, we saw that September has the lowest delay, so it's assigned score 1 compared to December and July that has like the highest delay, and they were assigned score 11 and score 12. So we have the day of the week delay score too. So that Thursday has the lowest delay score, right? So we went ahead to like map it to 1, and so that Tuesday has the highest, so we went ahead to map it to 7. So from there I went ahead to create the column in the data frame rather, and then use the dot map and then the hashtag int to map the score from year to their values in the month in this column, and then to convert it to type int. So feature reduction. So after feature engineering, I went to like remove those categorical some features that were not needed. So example, the categorical columns that have been encoded to numerical. So I went ahead to drop them. So and then month, day of the week, time block, all of these ones that were not needed that has been encoded, I went ahead to drop them. The dates was not also needed. I also went ahead to drop routes, destination, also went ahead to like drop them. Then the airline name, this have been replaced by the average values. I also went ahead to drop them. The flight column is also an identifier. I also went ahead to drop them. So for the origin and distance all, I plan to encode them in the pre-processing step. So I just left it as it's. So these are the number of, and I also just went ahead and like create a copy of the column and I dropped the values so that I don't know, for just backup, right? So these are the colors that I moved on with the data preprocessing. So in the data preprocessing, we went as like make sure the data is well prepared for modeling, right? So this is the level or the state that is going to we're going to prepare the data for modeling. So I went ahead to just do basic encoding. So one encoding of the origin flight, and since they had like sorry, since the number of values were not many, so the origin flight just had 3 values, distance or just has 3 values, the station clusters I think has just 4 5, the root class so has just 4 5. So I went ahead to use one of the coding so that we would not have to like deal with high dimensionality. Let's say the number of values for one or each of these column were like about 10, I would have probably considered label encoding or ordinal encoding as the case may be if they were actually ordered sharp. But then since they were not ordered, and then or not encoding is actually a good way to go in this situation. Then binary flags, red eye is left as is. Then we don't need to encode numerical columns, right? So we left them. Then for feature transformation, so we know that linear models are affected by skewness and scales of feature, right? So I went ahead to apply some feature transformation to our data for the linear model because I plan to use logistic regression random forest. So I just had to do some transformation. So for some of the features that were right skewed, I did log transformation, and then this feature contained negative value. So I had to do another form of transformation, which is the Johnson. So the Johnson transformation is not affected by negative values. So this was perfect for it. Then the average airline features too was also like mildly skewed. So I just had to do square root transformation. Then also standard scalar and min max scalar was used after transformation to standardize our values within the range. So we know that transformation changed the shape from non-normal to normal, while scaling change your range, right? Steps like adjust your range so that your linear models are not affected by the range of your values. So for the tree-based models, I just did transformation, then I skipped scaling because we know that tree-based models are not affected by the scales of our features, right? So yeah, and then I went as like move these two features, departure delay and arrival delay that we know that are going to cause data leakage. So since they are already features that we already know that they actually delayed, we need to like remove them because we're trying to actually predict if they'll be delayed. But we don't need to have features that will be telling us that yes, they were delayed. So they were dropped to prevent data leakage. So this is just the code block to or code blocks to do that. So these are the code. So when I create a pipeline, so a pipeline to combine all of those transformation steps into one place that we can see at once in one place rather, so that we can see in one place and then apply at once. So for the like I said earlier, for the linear preprocessor, we first do so we have to go with transformation before standardizing. Then for the tree based, we don't really need to do much of preprocessing because tree based are more robust to skills, right? They're not really affected by skills. So to apply my proposal step, also I since the data set is kind of a time series data, I had to make sure that there was order to splitting, right? So instead of randomly splitting, I had to make sure that I splitted on the time, right? So the first 80% was assigned to the train set, and then this last 20% will be assigned to the test set. So we're not inferring features. If it was a random splitting, right? We'll probably be inferring what we've seen from the future, and that's going to like affect our model, right? So our model is going to overfitting at that point, and then we don't want that. So this index-based splitting actually works to combat that, so that we are actually getting our data on the future at that point. After splitting the data, I went there to create the X-ray linear. So this one I applied the linear preprocessor to the X-ray. Then the X-test linear, I applied the linear preprocessor to the X-test. Then the X-tree pipeline, so I applied it to create the X-test train, X-test tree and X-test train. Yes. So to after processing my data, I have to like convert them back into a data frame so that I can actually see which feature is which. Pre-processing is just like make your data in some sparse number array. So I have to like convert it back so that I can see which feature is which and I can understand what is going on. This code blocks from here is just here to here is just what does that, converting to data frame and all that. So you can now see that this is what each feature or this is what the first 5 rows of our data set looks like at this point, ready for modeling. So the modeling approach was to build a um, multi-output model, right? That's going to predict departure delay at 15% and arrival delay. Sorry, departure delay greater than or equal to 15 and arrival delay greater than or equal to 15. And for this one, the metric of focus was going to be to maximize our recall, right? So we are focusing on reducing the false negative. So false negative is that saying that this flight is not going to be delayed greater than 15 minutes, but it actually ends up being delayed. So we want to focus on reducing the false negative. So that is why our metric of focus for this project is going to be maximizing our recall. So I went there to just define the evaluation metrics, and then since we are going to be focused on recall, you know that recall and precision they go in this direction. So we are going to focus on maximizing recall while getting a well-balanced F1 score. Right. So getting a well-balanced F1 score tells us that our precision is not so low that our model is not robust. So getting a high recall but also achieving a balanced or well-balanced F1 score is basically our goal. So these are like the measures I'm going to be instead of focusing on just accuracy. So yeah, we have the recall, the precision, the F1 score, then the coefficient matrix to just see the breakdown. So I have everything like broken down here. Then since this is a multi output, this is my first time working on a multi output prediction, and I think I enjoyed it to some extent. So some extra metrics were Hamming loss, subset accuracy that we used to just evaluate the effectiveness of the multi output prediction. So these are some extra modulation that I discussed, and you can always go ahead to read through. So in my workflow, let's try to like create functions for essentially like things that I'll be repeating. So if I create model and now I'm going to like evaluating those models, so I just like to like create functions for them. So I went to like define some functions. So first one is to define define a function to always like evaluate my model automatically. So I'll just input all of these parameters and it's just going to help me evaluate my model, just produce the results for me. So basically it's going to just going to do this. And doing this method make sure that I am evaluating each model on the same kind of on the same metrics, right? So I don't have to like start keeping track of, oh, I forgot to check accuracy for one, I forgot to check precision for the other. Do you understand? So using the function helps me like make sure that I am correctly evaluating each model the set of on the set of metrics that I had defined in the function, right? So also created the functions like plot confusion matrix, plot ROC curve, plot PR curve, creates your classification report, then plot feature importance. Here for this model, we actually want to understand which feature are actually driving our prediction, right? So I have to like create a feature, sorry, a function to always plot my feature importance based on my model performance, right? Also, yes, I have to like always log my model performance so that I can have a way to always view them. I don't have to like always go try to go back and see what's going on or try to remember what each model performance is. So I just create a function to help me like log when I train the model, I just log them immediately so that I can really score the table at the end and I can see or try to like go through each of the models that I've created to view their performance and just get a glance of everything. So after logging this, I try to like put on that function to just create the log into a data frame. Yeah, so this is another function to get the multi-output probability, right? Then another one to evaluate training performance. So we evaluate tests error, also evaluate training error. So this is the function to evaluate that. So starting with the logistic regression. So I went there to like fit the logistic regression using these parameters and then wrapping it in the multi-output classifier um function because this is a multi-output classifying task, right? So when I to wrap the base in the multi-output classifier and then fit it to the X-train linear state and the Y train, then after fitting when I to like make predictions for the train that is to evaluate the train error and then the test evaluate the test error. You also have to get the probabilities as well. So this is example of me using the evaluate training performance function. So after that, I just impose all the values that are necessary. Sorry, all the parameters that are necessary. Then I get the evaluation metrics. So you can see that the arming loss is there. So for the arming loss, as defined earlier, lower is better, and then for the subset average, higher is better. So defined earlier in the earlier model evaluation metrics definition. So yeah, and then the average PRC higher is better, right? So these are like so we can see that the recall for this LR basic model is 67%. This is actually a very good baseline model, right? So then we have to plot the confusion matrix to just see. So we have the true negatives, the true positives, the false negatives, and then the false positives. So this is just basically evaluating. So this is for the departure delay above 15 minutes, the arrival delay 15 minutes and above as well. So just to realize and see what's going on with the model. Then evaluating the model performance on our test set, can see that it achieves a recall of 62 and 61 zero sorry 62 and 61%, and that's actually a good baseline to work with. So I just wanted to interpret the metrics here to just write some summary. Then also so I better is to look at the feature importance. So we saw that for the departure delay, the time block score contributed the most, and then the month delay score, and then whether the flight, the red eye or not, actually contributed the most to our prediction. For the arrival delay, we also see that time block score and month delay score too contributed more to our our prediction. So this is just a code block to to view the raw numbers, right? Then I went there to log them in this markdown to just understand what's going on. Then after that, I went there to log the model using the log model performance function. So I had to write a note. So note is above average record sounds as a good baseline. You also went there to like fit a random forest model. And on fit my random forest model, I saw that the performance of the test train error is actually 70, and that is actually a very very good performance. At least it's a big improvement on the on the logistic regression, right? But taking the performance on the test, we see that it's 0.43, and that is a very very big drop. So that's telling us that the model is actually overfitting, and random forest is actually very very powerful. So it has the tendency to overfit, and it actually did. So this big gap of about 30 in between the test error and the train error tells us that the model is actually overfitting. So we have to do some hyperparameter tuning to understand. So my note was just performance is very poor due to overfitting. So I went ahead to do some tuning of my hyperparameters, so especially for random forest, to see if we can get it to not overfit, and we can improve the performance, right? So this is just me working on the tuning, and I did that already. I don't have to like call it now because calling is going to take time because it took time when I ran it the first time. So I'm just going to like go through my data. So after trying a lot of combination of values and all of that, I still ended up with a very high training metric, and the test performance did improve a little bit, but it is still poor. And I'm still actively trying to get the better understand. So I'm just going to leave this random forest as it is, and then I also want that to like tune the log reg. So this is like the code block to tune the log reg logistic regression model. And all that. I'm not going to run it again because I did it before and it took time. I'm doing it now. It's just going to take a lot of time. So yeah, and that's where we could, and I got the parameters. These are the parameters that we got, and I tried to like input them to see if it's going to improve the performance, but it really did not improve the performance for the model. And I just left it as it is. So I also tried oversampling sample. I ended up removing the code because it didn't really improve the performance. But yes, I'll just left two models that I built and my notes and their performance. So moving forward, I'm going to have to go back to my feature engineering and see if I can engineer more features that's going to help the models predictive ability. After feature engineering, I'm going to work on tuning their parameters. You know, data science versus iterative is not just one, it's not just one thing and you have to, and that's all. It's iterative, so you have to like keep iterating and going back and going back and going back and try to refine your process till you get your desired result. And that's what I'm going to continue to do. But I have to just make sure that I share this project with you guys, because if I continue to do that in the back end or without sharing, I'm not going to, I think I'm going to end up sharing the videos, the project at some point. So I started to share my progress to you guys, and I ended up using this logistical model for the predictor on the Streamlit app. But once I keep on refining and I achieve a better result for my model, I'm going to update the model, and I'm going to make an update video at some point at that point and share with you guys. But yeah, so I had to just stop there, and yeah, so this, we have come to the end of this video or this series, hopefully. And once I get a better model, I'm going to, I'll probably add a part three to the series and then update you guys. So, but then we've come to the end of this video, and thank you guys for watching. Thank you guys for spending your time with me and just trying to understand my thought process and just try to share my thought process with you guys. And I am so so grateful that I'm finally doing this. trying to share my journey with you guys. So don't forget to like, subscribe, and share the video. And let me know your thoughts, your feedback, your recommendations, whatever. If you work on any kind of project before, whatever you guys feel like I can do to better improve the performance of this model and project, let me know in the comment section. Reach out to me on LinkedIn, reach out to me on X, any of the platform. I am always ready and available to reply you and engage you and have a meaningful conversation with you guys. Thank you very much for joining me on this journey. I'm so grateful. And until next time, have a lovely morning, afternoon, evening, wherever you are. Bye, guys.